Hello my dear students. So here we have a question from JEE Advanced 2025 examination, and here question is the compound with most acidic hydrogen from these four compounds is. So how can we identify it? See, they have given four options. So in each of these compounds they have highlighted the hydrogen atom, and we need to identify in which of these four options the acidic hydrogen is, more acidic hydrogen is present. Yes. So how can we identify that compound? Yes, look here, in order to answer the acidic nature of organic compounds, we need to know the stability of that conjugate base. For example, AH is an acid. Let us say AH is an acid. This is an organic acid. Let us consider. Now, by releasing this H plus ion, that is what this. If I am saying this is acid, so what is it will do? It will releases H plus ion, and it will makes one A minus anion is formed. So now if this is an acid, so this A minus will be its conjugate base. I hope it is clear. After releasing H plus ion, the remaining negative part is called conjugate base of that particular acid. Now if the conjugate base stability is more, that respective acid will be more acidic. Now here apply that concept over here so that you will get the answer here. Okay, so now let us consider this is acidic hydrogen I mentioned now. So now by releasing this H plus ion, so by releasing this H plus ion, what is the conjugate base we are getting here? So we are getting something like this. So this is a conjugate base after releasing this H plus ion, right? So now this negative charge, this conjugate base is stabilized by like resonating structures like this. Yes or no? Yes. So it is having cross conjugation. So see, when the negative charge is coming here, so these pi electrons are shifting here, and it can be in the delocalization with this this external double bond, right? So that we will be getting a stabilized resonating structure like this. See, negative charge is shifted over here, so this pi bond is shifting here, so this remains like that only, and when it is shifting here, this pi bond is shifting onto this carbon, so that we will be getting a conjugate base resonating structure like this. Hope it is clear. Now it is having cross conjugation. What do we mean by cross conjugation? So whenever this pi bond is coming, negative charge is delocalizing here, so these pi electrons can shift to this side, as well as this pi bond can shift to this side, as it is in alternate position with this pi bond also. I hope you got what exactly cross conjugation is. So cross conjugation means to the same pi bond, so there are two possibilities to undergo conjugation with this side and also to this side, so that two resonating structures are possible. One is like this with respect to this pi bond if we shift, and if we shift with respect to this pi bond, we will get one more resonating structure. Okay, so that is about cross conjugation. Okay, so now you know continuous conjugation is more stable than this cross conjugation. Okay, hope it is clear. Conjugation is present, but that conjugation is crossed conjugation. So what I am saying, the continuous conjugation is more stable than this cross conjugation concept. Hope it is clear. Now let us discuss about this B here. Okay, so in case of B, now by releasing this H plus ion, so by releasing this H plus ion, so what is the negative part we are getting here? So we will be getting a negative charge like this. See, so here I will be writing. See, here we have negative charge now. So this can stabilize over here by conjugation, and when it is shifting here, so this pi bond will be shifted onto this carbon, this center junction carbon of this 5-membered ring, right? So that we will be having something like this. Double bond here and negative charge here. So now if you look into it properly, so what you are having, a cyclic 5-membered ring with two pi bonds here and one negative charge, which are in conjugation with each other. So this compound, this like species whatever we have highlighted, so that is aromatic compound, right? See, it is having cyclic structure, all carbons are sp2 hybridized. It means compound is planar into this manner, okay, into this stage, okay, this ring, and you know continuous conjugation of this pi electrons is taking place like this, continuous conjugation is taking place. It means continuous conjugation is there means it is more stable, and again it has 4n plus 2 pi electrons. How many electrons are there? 6 pi electrons are there in this given compound. So it means compound is aromatic. This conjugate base is aromatic. We know aromatic compounds are highly stable. Then this normal, non-aromatic and anti-aromatic compounds, right? So I can say this compound is highly acidic when we compare with this A. Okay. Similarly, if we remove hydrogen from here, so what is the negative negative part? We are getting conjugate base. So you can write like this. This is the acidic hydrogen. So it means negative charge is here after releasing this H plus ion from here. So after releasing this is the negative charge. So now if we shift here, again it will be having a conjugation like this, but the resulting species is not aromatic. This is a non-aromatic compound, but it is stabilized by conjugation. Hope it is clear. Okay. So here we are getting a non-aromatic conjugate base. Okay. Now here after releasing this H plus ion from here, we will be having a negative charge on this species. So I am writing here, yeah. So it will be like this. Now look here. So this can be stabilized by conjugation like this, but whenever it is stabilizing like this, see we have a continuous conjugation up to here. Yes, continuous conjugation is there, but the resulting species again it is also non-aromatic. Okay, we know aromatic compounds are more stable than the non-aromatic, right? So which is more stable conjugate base forming in these 4 options? Yes, option B is forming more stable conjugate base, that is aromatic ring is resulting from its after releasing the H plus ion. Therefore this compound is more stable by its aromatic nature. So the concept of this conjugate base is again depending upon what? Aromaticity concept. So they have linked acidic nature of organic compounds to the stability of its conjugate base, which is again depending upon the the concept of aromaticity. I hope it is clear now. So concept of aromaticity is very important. So this is again, I can say this question is again from the applications of aromatic nature or aromaticity concept. Now hope it is clear. You got the concept. Now I will be giving you one question based on this concept. Okay. So if you want to get the answer for this question, whatever I am giving, you just look into the charts. Short videos which I have did. So in that I have already explained about the answer. Okay. So you just give a try for solving this question. Here I will be giving you. Okay. Here I will be mentioning HA hydrogen, and here I am mentioning one more. Like this I will be giving you. Now tell me, here I am saying HA, HB. Now which hydrogen is more acidic? Identify HA and HB, which is more acidic. What is the order of acidic nature of HA and HB? Which is more acidic? Write in the comment box. I will be looking for your answer. So how can we answer this? Just release this H plus ion and get its conjugate base. After releasing the H plus ion, we will be getting a negative charge here. Then check stability of that the conjugate base. That negative charge species, you check the stability. And here also you release this H plus ion, this HB, whatever I mentioned. So after that we will be getting a negative charge here. Then check for the stability of that conjugate base and identify which conjugate base, which negative part of these two species is more stable. So that will be more acidic compound. That resulting compound will be more acidic. Hope it is clear right now. So if you really like the content, just click on the like button. If you want more such videos, just write in the comment box whatever the concept you require. You write in the comment box. I will be discussing in the upcoming session. Thank you for watching.